Welcome to the SAR channel, where sound and audio are demystified. When the compact disc, CD, came out in 1982, it was praised for having a huge storage capacity. But over time, it started to seem limited. Some audio experts also felt that the CD's design restricted sound quality. It couldn't handle the large files and high bit rates needed for surround sound and high-resolution audio. To solve this, Philips and Sony introduced the Super Audio CD, SACD, in 1999. SACD supports both stereo and multi-channel audio using a special single-bit system called Direct Stream Digital DSD. DSD uses a very high sampling rate, giving a flat frequency response up to 100 kHz and a dynamic range of 120 decibels in the 0 to 20 kHz range. SACD players can play both SACD and regular CD discs. However, SACD discs are not compatible with DVD or Blu-ray players. DSD data also can't be played on standard DVD or Blu-ray drives. However, SACD discs can include extra data such as text or graphics, but not video. SACDs are the same size as CDs and come in three types: single layer, one high-density DSD layer, 4.7 gigabytes, giving about 110 minutes of stereo audio. Dual layer, two high-density layers, 8.5 gigabytes total. Hybrid, one high-density DSD layer, 4.7 gigabytes, and one standard CD layer, 680 megabytes. An SACD player can read both layers, while a regular CD, DVD, or Blu-ray player can only read the CD layer. All CDs use PCM, pulse code modulation, to store sound, but Super Audio CDs use a different system called Direct Stream Digital, DSD. In DSD, the audio signal is turned into a stream of single-bit pulses using a method called sigma-delta modulation. Most standard analog-to-digital converters, AD converters, also use sigma-delta techniques. They first raise the signal's sampling rate, upsampling, then use a decimation filter to lower it again and convert it to PCM, 44.1 kHz for CDs, or up to 192 kHz for DVD audio and Blu-ray. Similarly, digital-to-analog converters, DA converters, use oversampling to push unwanted frequencies out of the audio range. DSD works differently. It also starts with a high sampling rate, but instead of converting to PCM, it keeps the original 2.8224 MHz sampling rate. The signal is stored directly as single-bit data without using decimation or interpolation filters. In simple terms, DSD captures the direct output of a sigma-delta converter running at 2.8224 MHz. DSD relies on sigma-delta modulation and noise shaping. The human ear can't easily hear very high-frequency noise, especially if it's not related to lower-frequency sounds. So, DSD pushes most of its noise above 20 kHz, where it's not noticeable. Advanced noise shaping filters, often fifth order, reduce audible noise even further. A simple low-pass filter can then remove the remaining high-frequency noise and recover the audio signal. In SACD, the analog signal is sampled at 2.8224 MHz, with each sample represented by one bit. This results in a bit rate about 4 times higher than that of a CD. The theoretical Nyquist frequency is 1.4112 MHz, but in practice, analog filters limit the frequency response to 100 kHz or lower to reduce high-frequency noise. When a CD is played, its data is sent through a digital filter. When an SACD is played, its DSD data goes to a DSD decoder instead. The DSD signal comes out as a single-bit stream running at 2.8224 MHz and is sent to a pulse density modulation PDM processor. A pulse current digital-to-analog converter then changes this pulse voltage into a pulse current. Finally, this current signal passes through an analog low-pass filter, which smooths it into a clean analog audio waveform for playback. DSD 64, 128, and 256 are different sampling rates used in direct stream digital audio. The higher the number, the higher the sound resolution and data rate. Each rate is a multiple of the standard CD sampling rate, 44.1 kHz. DSD 64 equals 2.8 MHz. 128 equals 5.6 MHz. 256 equals 11.2 MHz. Thank you for watching till the end. To better understand each video, make sure to watch the previous ones. Some may serve as prerequisites for the next. If you have any questions or opinions, feel free to leave a comment. Until next time, subscribe and stay curious.